Hi, this is Mrs. Secor, and let's finish that notebook on the OGT. We're going to focus on graphs now, if you can find this page in your notebook. The first one we're going to look at is a circle graph, and here's a typical question that they would ask you. They would say maybe the income for a family for the month is $35,000. And then they'd say, well, how much do they pay for rent? Well, what you want to do is multiply 35% of or times the 35,000. Okay, so we're going to multiply our income, I guess I'll put it this way, times our 0.35. And if you do that, I think you end up with $1,225 a month. That's how much they would pay for their rent. And you could do it for other areas too. All right. I'm just going to remind you how to make a stem and leaf plot. First, you need to find, let's see, these are two-digit numbers, so we will go through and find our smallest, which looks like 68, and our largest is 99. So that'll be our stems, 6, 7, 8, 9, and then we're going to go through the numbers and put them in the leaves, the last digit. Okay, so 99, 92, 86, 85, 74, 68, 71, 70, 85, 82, 83, 95, 80, and 90. Okay. A scatter plot. A scatter plot. This is not a line graph. You want to just plot the points. So this is talking about fat grams and calories. You might be asked to set up a graph. And so fat grams for our x-axis, calories for our y. You'd have a grid, and then you would space them out and plot the points. So a donut has 13 calories, fat grams, excuse me, and 306 calories. Corn chips have 13 fat grams and 200 calories. Pudding has 3 fat grams, 150. Cake, 13 and 230. Snack crackers, 6 and 140. Ice cream, 5 and 130. Yogurt, 2 and 70. And cheese pizza, 18 and 410. Okay, that's what a scatter plot looks like. Now it says, does the scatter plot show a positive, negative, or no relation? Well, you can see it's trending up. The more fat we have, the more calories we generally have. So this is called positive. Occasionally they might ask you to draw a trend line. So let's draw in a trend line. We know we have 0, we're going to have 0, so it's down here. So let's kind of eyeball it here. I think the trend line's something like that. Okay, this is called a trend line. Just some vocabulary. They might ask you that. Okay. Box and whisker plot. We're going to compare two ambulances, the times they take to get to the scene. So Metro has 13, I'll just tell you that, or 11 I think. So we'll put 11 spaces there. All right, and then we'll number them. I think it goes, there's a 4, a 5, a 6, then there's an 8 and 9. Okay, and then there's a 10 and another 10, and then an 11, 12, 13, and a 14. Okay, so I like to do this. I like to put a box around the group. So there's 11, so there's 5 up here and 5 here. It's kind of really, this isn't the box and whisker plot, but it helps me focus on, okay, there is one of the main points. I need 5-point summary. So the median is 10. The minimum is 4, and the maximum is 14. Now I need the median of this box, which is 12. I need the median of this box, which is 6. There, I have my 5 points. Now the next one. Okay, this one has an even amount, and there are 12, I think. 10, 11, 12. Okay, and I think there are 3, 3, 3, and then 5, 5. I thought there was another 5. 5, 5. Okay, I guess not. And then there is a 6 and 7, 8, and then where does it go? 10, 11, 12, 15, 10, 11, 12, and 15. 10, 11, 12, and 15. Okay, good. Now I'll box this off. Okay, so there's 12, so there's 6 up there and 6 here. Okay. The minimum is 3. The max is 15. The median, what's in between there? 6.5, right, between the 6 and 7. And the one in between here would be 4, right? Between 3 and 5 is 4, the median. And between 10 and 11 would be 10.5. Okay, now we have to draw a line with the numbering system, and now we're going to put the 5 points on. Let's take Metro. Okay, so 4, 6, put the dots up, 10, 12, and 14. Okay, and then we draw a box around the second and fourth number, and that's our median, goes right through there, and then the whisker and the whisker. Okay, now the other one. Arrow. 3, 4, 6.5, 10.5, and 15. And we draw the box, the median, and the whiskers. All right, and then if we compare them, which company would you rather call if you wanted to get fast service? You would want to call Arrow. Why? Because see how almost 75% of the calls the ambulance has reached the people, the victim, where only 50% have been reached at that time. So Arrow is the better service. Call Arrow. All right, equations. A party planner charges a flat fee of $100 to plan a party plus an additional $15 per guest. If N is the number of guests and C is the total charges, write an equation to determine the total charges. All right, so the cost, and you remember, you're wanting a rate of change. So this is what's changing. $15 per guest. So that's our 15x, depending on how many people we have. But we know we have a certain flat fee of $100. That's what our equation looks like. It changes by how many people. We have another one like this. A salesperson's salary includes a base pay of $800 a month plus a 2.5% of the monthly sales. If X is the sales per month and Y is the total salary, write an equation to determine the total salary for any month. Okay, so the salary, Y is the salary, Y equals, okay, it's going up. This is our rate of change. I'm going to make it a decimal. Move that decimal point 2 places to the left. Okay, X plus our $800. You know, I think I messed this up. It shouldn't have been X here. Didn't it say let N be the number of guests? So I'm just going to change that real quick. Boom. And make it an N for number of people. Okay. Next one. Functions. It might ask you, is this a function or not? Well, you cannot have the x's be the same if it's a function. Okay, so do you see here we have 2 2's for the x's? This is called domain. The domain, the x value cannot be the same. So these are no. All right. Another way to test it is if you see the graph, you do the vertical line test. If you can draw a vertical line through any place on the graph and it only touches one point, yes, we have a function. Notice this one's not going to work. Okay, we crossed in 2 places here. Another place you could have done it, but you can see how x is 1, has a value of 3, but x is 1 again and has a value of, I don't know, negative 3.3 or something like that. So y has that value, I mean. So x has 2 values for 1. That is not a function. Vertical line test. Okay, another vocabulary thing that appears on the OGT a lot is called inverse relationship. What it means is as x is going up or down, the y is doing the opposite thing. So here we have our fruit. The numbers are going up, right? They're going up 0 to 1, 2 to 3, 3 to 4. It's going up. But notice that the y's are going down. This is called an inverse relationship or an inverse function. And slope, again, we're talking about all these graphs. Now let's try to read what the slope is of this line. Well, I see it crossing at 0, 0, and I see another point right here. So m, that's the symbol for slope, is rise over run, up 1 over 2. 1/2 is the slope. Let's write an equation for this line. The equation in the slope form is y equals mx plus b. Okay, so let's just plug in our m. Our m is 1/2 x. And then what is our b? Well, our b is where it crosses the y-axis, and we can see it crosses at 0. So the equation could be written this way, but it'll probably be written like this. 1/2 x. And the last one, a parabola. Okay, let's just graph it. See if you can take the function, plug in values for x. Here they are. I've given you 4 to put in there for x, and then figure out what y would be, or f of x, I guess I should say, f of x. It's another name for y. And then we'll plot it over here in the grid. Okay, so if I put a negative 2 in, negative 2 squared plus 3 times negative 2 plus 2, I think I get 4, negative 6, and 2. I think I get, is it 0?